Welcome to www.happynumbers.org. Today's lesson on polynomials is what we do with exponents when we are dividing polynomials. If you recall what we do with exponents when we're multiplying polynomials, if we're multiplying 3x times 4x squared, we know we multiply the coefficients 12 and we add the exponents. Now we know this is x to the first and this is x to the second, so that gives us x to the third. But now we're going to work on division. So here is a rule, and I just want you to, I'll read it to you, then I want you to put your video or DVD on pause, copy this rule down, and then I'll explain it to you. It says, rule, to divide like variables, subtract the exponent of the denominator, or the bottom part of the fraction, from the exponent of the numerator, or the top part. Put your video on pause, copy that rule in your notebook, and then turn it back on, and then we'll talk about this. Well, let's take a problem like this now. Let's take y to the 6th power divided by y to the 2nd power. Okay, well, we can write it like this: y to the 6th power divided by y to the 2nd power. Now, this is our this is a fraction. This is our denominator. This is our numerator. Now, the rule says to divide like variables. Both of these variables are the same because they're y's. To divide like variables, subtract the exponent of the denominator. Well, this is the exponent of the denominator from the exponent of the numerator. So it says to subtract 2 from 6. So this would be y to the 6th minus 2, which would be y to the 4th. Okay, so let's just go over this. Y to the 6th divided by y to the 2. We can write it this way: y to the 6th power divided by y to the 2nd. The rule tells us to subtract the exponent of the denominator, the bottom part of the fraction, from the exponent of the top part of the fraction. So we would get y to the 6 minus 2, which is y to the 4th. But let me show you why that's so. Y to the 6th really equals, divided by y to the 2nd, really equals y to the 6th is y times y times y times y times y times y. That's 1, 2, 3, 4, 5, 6 y's. Divided by y to the 4th, y to 2, 3, 4. Well, these y's can cancel out, and we're left with 2 y's, or y to the 2nd. So that's why the rule works. Let me show you another problem like that. Let's take one that looks like this. X squared divided by x. Okay. Well, we can rewrite it: x squared divided by x. And this is really x to the first, right? We don't write that. Well, the rule tells us to subtract the exponent of the denominator, the bottom part, from the exponent of the top, which would be x to the 2 minus 1, which would equal x to the 1, or just x. And here's why. X squared divided by x is equal to x times x divided by x, and the x's cancel out, and we just have x. So that's how simple it is when we're working with exponents in division. Now, there is a special case. Well, first of all, let me give you some examples in that first. let's I'm going to ask you to do these. B to the 6th divided by B to the 3rd. I want you to do that one, and let's have you do, let's take R to the 3rd divided by R. You work those two. Put it on your video or DVD on pause, and then work that problem. Okay, let's see how we've done here. We have B to the 6th. Whoops, my bad. B to the 6th divided by B to the 3rd, which is equal to B to the 6 minus 3, because the exponent of the bottom part, the denominator, minus, take away from that, and that gives us B to the 3rd. And the reason that's so is 1, 2, 3, 4, 5, 6 divided by 1, 2, 3. These would cancel out, and we would be left with B to the 3rd. Excellent. Let's take a look at the R one. R to the 3rd divided by R, and this is R to the 1st, as you know, would be R to the 3 minus 1, which would equal R to the 2nd. And the reason for that is R to the 3rd, which would be R times I divided by R to the 1st. They cancel out, and it would be R to the 2nd. Very good. Very good. Okay, now we have a special case, actually two special cases. First special case is a problem like this. Y to the 3rd divided by Y to the 5th. Well, that would equal Y to the 3rd divided by Y to the 5th, which is equal to Y to the 3 minus 5. That's interesting. It's interesting. And Y to the 3 minus 5 would be Y to the negative 2 power. Y to the negative 2 power. Now here's the special case. Anytime you have a variable to a negative power, that is always equal to 1 over the variable to the positive power. Now let me say that again. Anytime you have a variable that's equal to a negative power, like y equals negative 2, y to the negative 2 power, that is equal to 1 over y to the 2, to the second power. Let me just show, let's take a to the negative 4th power. Well, that is equal to 1 over a to the 4th power. Let me explain this, in fact. This can be sometimes a little confusing concept. Let's take y to the 3rd divided by y to the 5th. Well, that's equal to y times y times y divided by y times y times y times y times y. Now, if I cancel out the 3 y's, what I'm left with is 1 over y squared. That's why y to the 3rd divided by y to the 5th is really equal to y to the negative 2nd power. But y to the negative 2nd power is equal to 1 over y squared. Let me give you one more example. Let's take x divided by x to the 3rd. Well, okay, so we have x divided by x to the third. Now this would be x to the 1 minus 3, because this is x to the 1 minus 3, which is really equal to x to the negative 2 power, which, as we know, is equal to 1 over x to the second power. And here's why. X divided by x times x times x. If we cancel this out, x goes into x one time, x goes into x one time, and we multiply, so we have 1 over x times x is x to the second power. Well, if that's confusing to you right now, that's okay. If you want to stop the video or go back over this and take a look at it. But if you're really having difficulty, all you really need to remember is anytime you have a variable, let's take b to the negative 5th power. Anytime the variable is to a negative power, it's always equal to 1 over the variable to the positive power. So b to the negative 5th is always equal to 1 over b to the positive 5th. So that's the thing you need to remember in working with it. Okay, let's take a look at one other. Let me check my time and see how I'm doing here. One other problem. Oh, I've got 24 seconds left. Well, I may go over a little bit on this, but I'll try and do it quickly. Let's take a look at a problem where we have x divided by x. Well, that's x to the first divided by x to the first. And x to the first divided by x to the first would be equal to x to the 1 minus 1, which is equal to x to the 0 power, because 1 minus 1 is 0. Anytime a variable is equal to the 0 power, that variable is equal to 1. Okay, so a couple of special cases here. A to the negative 3 is equal to 1 over a to the third power. A to the fourth over a to the fourth is equal to a to the 4 minus 4, which is equal to a to the 0 power. Any variable equal to the 0 power is equal to 1. Okay, well there it is. Those are the exponents when you're working with polynomials and in division. So, quick recap. Y to the 6th divided by y to the 3rd is equal to y to the 6 minus 3, which is equal to y to the 3rd. You subtract the exponents. Y to the 3rd minus y to the 6th, the opposite, is equal to y to the 3 minus 6th, which is equal to y to the minus 3 power, which is equal to 1 over y to the 3rd power. And y to the 2nd divided by y to the 2nd is equal to y to the 2 minus 2 power, which is equal to y to the 0 power, which is equal to 1. There you go. There you go. That's the rules. Now, again, if this was a little confusing, this is an important concept, then go back over the video again, take some notes, and take a look at the problems. Thank you very much. I really appreciate your attention. See you next time.